Welcome to this session on classification algorithms, a key tool in learning analytics. Today, we'll cover what classification algorithms are, why they are important in learning environments, and how to measure and improve them. Let's get started. A classification algorithm is a machine learning model that predicts the most likely class for a given input. For example, it can classify an email as spam or not spam based on the text. In education, we use it to classify students into groups based on various factors, such as learning styles or activity levels. Why is it important to classify students by learning styles or behaviors? Here are 3 reasons. Personalized learning. Once we know a student's group, we can recommend learning paths proven successful for similar students. Optimizing tutor time. Tutors can focus on students who need more support, like those with less prior knowledge. Content adaptation. Based on group performance, we can recommend different tasks. For example, full-time students might dive deeper into topics, while working students may get more concise materials. To create a classification algorithm, we need a labeled dataset, where each sample is already classified. Let's say we want to classify students as either weekday learners or weekend learners. Our dataset should include characteristics like the days and times students log into the platform. There are various algorithms to choose from. K-nearest neighbors. This algorithm measures the distance between new data and labeled examples, assigning it to the closest group. Logistic regression assigns a probability to each class and picks the one with the highest likelihood. Support vector machines creates boundaries between groups and classifies new data based on which side of the boundary it falls. After creating a classification algorithm, we need to test its performance. One popular method is the confusion matrix. It records how often the algorithm correctly or incorrectly classifies data. The figure shows an example of a confusion matrix for the case of binary classification, where there are only 2 classes to which the new sample can belong. Another measure is the AUC, or area under the curve, which helps assess the algorithm's ability to distinguish between 2 classes. Over time, the characteristics of your groups might change, so it's essential to regularly evaluate your classification algorithm. If performance drops, you can retune the algorithm using updated data. Another strategy is to periodically remove older samples and replace them with newer ones to keep the model relevant and accurate. To recap, classification algorithms help us group students based on their behaviors and learning styles. This allows for personalized learning, better use of tutor time, and smarter content adaptation. We've also covered how to create, evaluate, and improve these algorithms. Be sure to review the extended content of this lesson before your test. Thank you for joining me, and see you in the next lesson.